This is, of course, the centenary of the discovery of diabetes, and EASD is celebrating in many different ways. And to talk us through the history of insulin, I have two people who are in two places that are of incredible importance in the whole story of insulin. We have in Canada, at the University of Toronto, Professor Dan Drucker, and in Copenhagen, also extraordinarily important, as you'll hear in the history of insulin, is Tina Vilsboll. So welcome to you both. Hello.
Hello there.
So Dan, let's start with you and the University of Toronto. So Banting was a country surgeon and orthopedic surgeon, and he suddenly decided to get into insulin research. How did that happen?
Well, he was actually instructed to teach the medical students, and he was supposed to teach them about carbohydrate physiology and metabolism. And he got really excited about the area and came up with the idea, which wasn't original at all, that maybe the pancreas was involved, and thought he could do some experiments. But the school that he worked at the time, the University of Western Ontario, was a clinical school, and there were no laboratories. And he traveled down the road. It's about 100 miles or so, from Western Ontario, London to Toronto. And he managed to convince the chair of biochemistry, who is a world expert in carbohydrate metabolism, that he should be provided some funds and dogs and laboratory assistance. And it's actually astounding that he wasn't just kicked out of the office and sent running back to London. And that's how he managed to get the opportunity to do that research in the summer of 1921.
And the first patient that they treated, Leonard Thompson, things did not go well, did they?
No, so, they had no purification, really. They weren't really aware of, bacteria, and the extract was crude. And poor Leonard Thompson got this massive abscess in his leg, which if this happened today, Tina knows as a clinical investigator that she would have had to report this, and they would have shut down the program immediately and placed a clinical hold on the whole story. But there was no regulation at the time, and Collip managed to purify a much greater, pristine extract a few days later, and this one worked much better. Glucose was reduced very excitingly, and there was no abscess, and off to the races they went.
But the big problem was that although they had insulin, they had it in this purified form, they actually didn't know how to make it in large quantities. And I remember you saying to me that actually it was a PR nightmare for the University of Toronto because the world and his wife wanted insulin.
Yeah, you can imagine. Exactly right. So this went out over the wires and to the newspapers all over the world. And so, if you had type 1 diabetes, you literally had a death sentence facing you. So everyone was clamoring for insulin. And we had a production facility, the Connaught Laboratories in Toronto, that could produce some insulin at a reasonable scale, but nothing that could meet the demand of North America, let alone Europe. And so, we were very fortunate that we had interest from Dr. Close, who headed the Lilly Research Laboratories, and that's how we started to produce insulin in collaboration with Lilly for North America. And then, of course, the famous story of August and Marie Crowe that Tina probably was taught in school, who helped galvanize insulin production initially in Denmark and then for Europe.
So let's bring Tina in here. So Denmark played a particularly important role in the history of insulin. Tell us a bit more about that.
Yeah, well, Dan initiated the talk. August and Marie Crowe were really tremendous. I mean, I was brought up with those two, and especially I'm a big fan of Marie Crowe. She was actually the third woman in Denmark getting the DMSC, which is the highest academic degree you can get in Denmark. And so, but their partnership was central, and the collaboration that they did. Marie, she got diabetes, and August Krogh, he was really a nerdy guy. He wasn't really into the area of insulin, but together, that's what the story tell and all the books say, that together they actually managed to have not only a marriage, but also a collaboration in how to purify it, how to collaborate with a lot of people, because it's not made by only Canada or Denmark. A lot of people collaborating on this, competing, which science also is, in get it into in a purified tool or whatever, which can be expanded to a lot of patients, because that was the problem for a long time, that they needed too many pancreases to actually save enough patients.
And there were two things that were central to the reasons why Denmark and North America succeeded at the beginning, and they have to do with pigs in Denmark and with cattle in North America, because you needed vast quantities of slaughtered animals for the pancreases, and you had that in the giant stockyards of Chicago in the US, but in Denmark you had a lot of pigs, didn't you? And they were the source of.
Yeah, that's right. That was actually the very, very large problem in the beginning, that you needed a high volume before, everything developed and purification, everything went on. So yes, I think that was, good scientists and the surroundings around the scientists back then were central in the development. And also, we had Noble, we had Nordisk, and also I think people at an early point realized that this is important, not initially as a money-making machine, but saving lives, as Dan said. It was a death sentence back then if you had diabetes. So the whole idea was really to save patients and young individuals in many cases, or pretty much always.
And Dan, I'm really struck by the similarity between the development of the COVID-19 vaccine and the discovery and scale-up of insulin production. They have lots of things in common, I think, and particularly the clamour to make it available to the whole world. And I think I'm right in saying that Banting, actually, the University of Toronto, and he sold the patent for just $1.
Yeah, we have, you're so right. So we have today these discussions about, the COVID vaccine for all and vaccine equity globally, and making sure that everyone has access to at least one or two vaccines before some people have 3 and 4, doses, et cetera. And the same conversations were being taking place in the 1920s, that we needed to provide insulin to as many people as possible. And still today, we have a problem globally, even in some of the richest countries of the world, in delivering a life-saving drug at an affordable and what many people feel should be a free, there shouldn't be a price to pay if you have the misfortune to have a disease that's not your fault and you need a drug to save your life. So this, I think, is something that the World Health Organization and other bodies are looking into. And I think it really speaks to the values of humanity and different healthcare systems in different countries, that we can do a much better job in equitable distribution of resources and saving people's lives, whether it's clean water or vaccines or insulin, even today.
So the story of insulin, Tina, is one that the company Novo Nordisk in particular is very closely associated with. And the problems of supply of insulin continued actually for quite some time. I know there was a suggestion at one time that fish or even whale pancreas should be used as a source of insulin. Apparently whale has an exact homologue to human insulin. There you are. A random fact, I throw it out for you. But what happened next as far as Novo Nordisk was concerned?
Well, I think still, or again, it was the scientists' effort to save more people, to develop this whole idea about making a good insulin to everyone, and they realized that they had to develop it. Eventually, recombinant insulin was developed, human NPH insulin was developed, and we're not there yet. We still have a long way to go before we have the perfect insulin. But many, continuous effort from the scientists really made a great change during decades, and we've had 100 years, but I'm really looking forward. I won't be there for another 100 years, but just the next 5 years will really be interesting. Looking at once weekly insulin, oral insulin, closed loop, fast insulin in pumps, and so on. So the future is still bright, and there are so many things still to be invented and discussed and developed from the scientist's point of view.
So, Dan, I'm going to be slightly provocative and say, of course, insulin has been hugely successful discovery, but actually it's not the cure for the cure for diabetes that it was proclaimed by all the media at the time. And I wonder if, in celebrating, we should also recognize that as yet we have not cured diabetes. Oh, Dan, I can't hear you.
Yeah, that's not provocative. That's 100% correct. And I think we, in the course of celebration, are promoting the value of research and, celebrating the success of the engineers that Tina mentioned are now providing us with, closed loop systems that can sense glucose and automatically deliver insulin, relieving an individual from, the requirement to check blood sugar and adjust insulin constantly. And then we have the stem cell biologists and the immunologists racing to develop human insulin-producing islet cells that are not recognized by the immune system and might actually deliver something very close to a cure. So I think we're going to see tremendous progress in both these areas continuing over the next 10 years. And Tina and I are going to continue to take our low-dose metformin and rapamycin and hope that our aging is slowed so we can really be there to witness the cure for type 1 diabetes.
And there does seem to be a sense at the moment, I'm getting this very strongly from EASD this year, of really rapid acceleration. We're seeing that in the treatments for type 2, but I'm also seeing it in the possibilities for a cure for type 1. Dan?
Yeah, I think the progress, we have clinical trials now for stem cell derived islets, and we have both companies and academic consortium really being very active, and we're figuring out ways to make beta cells that are not recognized by the immune system. And it'll be trial and error, and it won't work perfectly, but I think we really have a tremendous amount of momentum now scientifically, and I'm very optimistic about the ability for scientists to deliver islets. Now, there are going to be barriers. It's going to be expensive initially, and it may not last as long as we would like, and we'll have to solve these problems. But I'm very confident in the ability of science to meet these challenges.
Now, we've talked there about the continuing evolution of insulin, but I want to go back to what happened after the discovery, because Banting and MacLeod won the Nobel Prize in 1923, but it really wasn't a happy. Toronto was not a happy place at that time. Dan, can you tell us what happened?
Sure. So, I just want to come back first to something that Tina said, because she called Professor August Crowe a nerd, and he may have been an unusual guy, but he had also won a Nobel Prize. So he was not really a shabby person to have contributed to the story. And, the Nobel Prize Committee, as you know, even today, has a limit of 3 individuals that can be recognized with the Nobel Prize in Medicine or Physiology. So you can imagine that they're sitting there with these 4 names, Banting, Best, McLeod, and Collip. And, should they pick 3 and who should they leave out, or should they pick 2? And it cannot have been an easy decision. McLeod was the internationally recognized scientist. The Nobel Committee knew of him. They would not have heard of any of these other individuals and picked Banting since he instigated the research. But immediately, as we know, Banting shared his Nobel Prize with Best, and McLeod shared his Nobel Prize with Collip. And it's really unfortunate that we could not have had all 4 recognized appropriately, because I think they each made seminal contributions and deserve to be recognized.
Yes, if Collip hadn't done the purification, then it wouldn't have gone any further. Tina, who are the major figures for you in the subsequent history of insulin? You've mentioned some, but who for you really stands out? I mean, I guess there are the people like Fred Sanger who sequenced the insulin, but there's also Dorothy Hodgkin and its 3D structure, and of course Rosamund Yallow as well. But what about, the clinicians that were involved?
Well, the clinicians were really important, and they're still important today in Denmark, because they actually managed to establish what the Steno Diabetes Center is. We had one Steno Diabetes Center in Copenhagen initially, and now, based on, you could say, Novo Nordisk and Novo Nordisk Foundation, we have the possibility in Denmark to have actually a huge and very important funding for further research within the area of diabetes. And that was funded back then by Haedorn, who was very central clinician at Steno Diabetes Center. And it's just wonderful to see still the old buildings are there. And they initiated the whole idea with the patient in the centrum, taking care of the patient 24/7, and really they managed back then to establish both what I really enjoy about being a scientist today, clinical relevant, like interventional research around the patient. And that has been extraordinarily important and still is. I had the motto, do patients in science and science in patients. And I think that was established back then 100 years ago and really accelerated the whole science that Denmark, and I know it's the case in Toronto and many places in the world, have continued.
And what's great, actually, is in both your centres, diabetes research has continued to be of the highest quality and really world-leading. And that's not always the case with discoveries. Sometimes you get a discovery and actually that department then falls behind. But you have both, if I may say so, you are both really in places that have outstanding diabetes research to this day. I don't think I'm over-flattering you, Dan.
No, I think we're very lucky. So, one of the people who drove the modern era of diabetes research in Toronto, many people knew him, was Mladen Vranic, who was the chair of physiology and an expert in insulin action, trained many of the leading experts today. And Mladen was, the last postdoc of Charlie Best. So we had this direct line from the discovery of insulin to today, the modern era, where we had people who really had an immediate connection to the story and the scientists. And I'm sure Tina feels the same way, but when you work in places that have had such major contributions to diabetes research, you have this sense of, I'm going to call it pressure, that remember where you are and what was done here to make a difference. And one needs to work very hard to meet those expectations. And it's a healthy pressure, but the history surrounds us every day when we walk in the room, wherever we are, I think in Toronto and in Copenhagen.
I can see you nodding. Do you feel that weight of history around you, Tina?
Yeah, I do indeed. And what I also love about the history is that, yes, it was based on insulin, and it's right that insulin is not a cure. It's a really good treatment. But things have also changed markedly. I remember 20 years ago when I went to my first conference and saw Dan being there, you know, the GLP-1 really bright guy, and Dan and Michael Naug and Jens Juul Holst and I were like, oh, this peptide is interesting. But people were really, is it that interesting, and so on. So just being on this journey for more than 20 years, also, you know, putting insulin, having insulin in our toolbox as extraordinary, important backbone, but also developing the clinic towards another interesting peptide, which GLP-1 is. It has been, you know, fantastic to be part of that journey, and it's absolutely right what Dan say. You feel an obligation to continue to do world-class science and having still the patient in the center, and that's, for me, the most important thing in my both clinical and research life.
So the discovery of insulin clearly matters to EASD and to the community of people living with diabetes and to diabetologists everywhere. But actually what I wanted to do as we come to a close is put the discovery of insulin in the context of all medical discoveries, because I think actually insulin was really a first in many ways. Dan, how do you think the discovery of insulin sits within the kind of pantheon of medical discovery?
So I think we can look at it several ways. So it's clearly not, type 1 diabetes is not a disease that affects hundreds of millions of people worldwide. But on the other hand, if we go back to the 1920s, you know, the state of medicine at that time was not well developed. We did not understand disease physiology. Physicians were using tinctures and extracts and even leeches and bloodletting, and you could not make a perfect scientific diagnosis and then say, because I know what your diagnosis is, now I know that this is the medication or treatment for you based on science. So insulin revolutionized, I think, the place of science and medicine. It allowed physicians to say, we understand perfectly what goes wrong with type 1 diabetes, and we have the precise medication to treat this disease. So it was really the first example of truly personalized medicine in the modern era. We didn't have antibiotics. We didn't have cardiac glycosides. We didn't have the ability to treat the vast majority of diseases. So I think it really made medical schools and research institutes take note that an investment in research would really pave the way for the modern era of medicine that we take for granted today.
And another thing about the discovery of insulin was it showed the absolute importance of industry, because without industry, it wouldn't have been possible to scale up the production, and insulin would have failed then as a treatment because it wouldn't have been widely available. But Tina, there was something else that insulin did. It was the first time, I think, that patients were taking charge of their own treatment. That had never been done before. So when patients were injecting themselves, previously the only people who'd been injecting themselves were cocaine addicts. That was like Sherlock Holmes was a classic example. But it really did something for patients in a way that actually has not been seen in other diseases, and certainly not until that point in time.
Yeah, you're absolutely right. And treating type 1 diabetes is actually, you get a lot of, you know, satisfaction out of it, because the vast majority of them, they really know that they need this life-saving treatment. They have a lot of knowledge about glucose, metabolism, carbohydrates. So they really take a huge responsibility of their own body, their own disease, which is interesting. And I could, you know, really imagine what an extraordinary situation they were in back then. And again, that I think Steno and the whole clinical intervention around the patient, making this collaboration with the patient central must have been fantastic to have been a doctor back then and really have a good collaboration with your patient. I wish I would have been there. But if I could just add on your other comment with respect to pharmaceutical companies, you're absolutely right. I mean, without them, we don't know what would have happened, but Dan and I, we do in general work with the pharmaceutical company in a very transparent way. And I think we have the patients and they have a machinery for drug development. And I think that is important that we have a collaboration, because if not, previously we wouldn't have been where we are today, and we will have to be transparent and expand our collaboration with the pharmaceutical companies. And I think people like Dan and I are important also to tell the pharmaceutical companies what's okay and what's not. So yeah.
Well, thank you.
Central.
Thank you very much, both of you. I mean, the history of insulin is really extraordinary, and I do urge you to go and have a look at some of the books that have been written about it. There are so many fascinating aspects to it, and we are celebrating the history of insulin this year and next year, which is the treatment of the first patient in 1922, and of course in 2023 as well, because that's the centenary of the first Nobel Prize given to Banting and Best. So the celebrations all round, and it is a wonderful story which is continuing to evolve. The history of insulin is not yet finally written.